Hello and welcome to this video on exercise 5e where we will be looking at solving quadratics. Okay, so we have been factorising so far. We're going to look at actually solving, and in a minute I'll get into what that actually means. But as a quick review, this is from the end of exercise 5e, we may as well look at the factorization methods we've looked at so far. So we've looked at 1, inspection, 2, the cross method, and 3, completing the square. Now, when would we use these? Well, inspection, okay, is when the coefficient, okay, is equal to 1. Okay, we try and use that first. The cross method, when do we use that? Okay, well, that's when the coefficient does not equal 1. Okay, and then when do we use the completing the square? We use that when the coefficient equals 1 and inspection didn't work. Okay, inspection was too hard, we couldn't see the numbers that we need to use. Generally that occurs when we've got fractions as either the constant term or the coefficient of x. Okay, and when I'm talking about the coefficient here, I'm talking of the ax squared. We're talking about the a. Is it 1? Is it not 1? And then it is 1 here, but inspection doesn't. So let's get into it. Okay, so solving quadratic equations. Now all this factorization is all about getting our quadratic into a form of brackets, and this is why, so we can use the null factor law. So what does the null factor law says? It says if the product of any two numbers is 0, then one or both the numbers is 0. So, okay, well, what does that mean? Let's have a look quickly at what's 5 times 0. Hopefully you're saying to yourself, oh, it's going to be 0. What's 0 times a? Well, anything times 0 is 0. Okay? But what if we're given a situation where a times b is equal to 0? Okay? Looking above, looking at this situation, if we have a times b equals 0, that means either a has to be 0 or b has to be 0. They don't both have to be, but at least one of them has to be 0. They both can be, but at least one of them. So let's read this again. If the product of any two numbers is 0, so if the solution is equal to 0, the product of two numbers, a times b, then one or both the numbers is 0. So either a is equal to 0 or b is equal to 0. So that's what the null factor law says. The next question you should have in your mind then is, well, how can we use this when we why are we factorizing? How can we use this in quadratics? Well, let's look at the situation below. If two or more factors multiplied together equals 0, so factors is the same as numbers, then the solutions can be found by equating each factor separately to 0. So the solutions can be found. So solutions. What does this word solution mean? We're actually finding what x needs to be to make this equation true. Okay, we're finding x. Okay, and the solutions can be found equating each factor separately to 0. So just up here, we have a times b equals 0, either a equals 0 or b equals 0. So when we factorize, we get a set of brackets multiplied by a set of brackets. Effectively, we've got a times b equals 0. So either this first bracket, okay, just here, needs to be equal to 0, or the second bracket needs to be equal to 0. And with quadratics, generally this now means we're going to get two solutions, two different numbers. So can be found by equating, so we're letting it equal to 0. Okay, we've let this bracket equal to 0, and then we've let this set of brackets equal to 0. We then just solve like normal using our symbolic manipulation skills, algebra. Okay, take one, add 1 to both sides, so we get x equals 1, or in this case we take 3 from both sides, we get x equals -3. So that is using the null factor law by recognizing that if we have two things multiplied, it can actually be more than two things. We could have 5 things multiplied as the product of them. If they all, when multiplied together, equal 0, at least one of those factors, one of those numbers up here in this case, a or b, or factor, needs to be equal to 0 for that equation to be true. One of them has to be equal to 0. So let's use this. Let's use this null factor law. So applying the null factor law, solve the following. Okay, so again, we've looked at factorizing. The whole point of factorizing is to get it so we have bracket times bracket equals 0, or factor times factor equals 0. So that we can then use the null factor law. So let's do that. X minus 3 multiplied by x plus 4 equals 0. We can write, therefore, x minus 3 equals 0, or x plus 4 equals 0. So rearranging, we get x equals 3, or x equals negative 4. And if we substitute that in, if we put 3 minus 3 in here, that gives us 0. We put the 3 in again, 3 plus 4 is 7, but 0 times 7 is still 0. And same, we put negative 4 and we get the same solution. Now, looking at this one, we don't have two sets of brackets. That's all right. We still have a factor. We'll have a factor multiplied by another factor equals 0. So we can say, therefore, x equals 0, or 2x minus 1 equals 0. So we get 2x equals 1, x equals a half. Okay. Now, this third one, it doesn't actually have equals 0 written on there, but we're going to write it in because we're being asked to solve. Okay? We're finding what x is. We're not just factorizing, we're finding what x is. Now, this 3 out the front, you're probably going, oh, is that an issue? Well, not really, because if we divide this side by 3, divide this side by 3, that 3 disappears, and we're left with x minus 1, 3x plus root 5 equals 0, because 0 divided by 3 is still 0. So that term disappears. So we can say, therefore, x minus 1 is equal to 0. Now, you don't actually always have to write the word or. You can just use a comma. 3x plus root 5 equals 0. So we solve this. We get x equals 1. Or what do we get? We get 3x equals negative root 5. Or x is equal to negative root 5 on 3. Now, D down here, this is a little bit more difficult. Okay, the null factor law, we said if the product of any two numbers is 0, that means equals 0. We can use the null factor law. In this case, we have equals 1. So this doesn't work. Okay, we can't use the null factor law straight away. We can turn this equation though into x minus 2 minus 1 equals 0. Okay. Now we have it equal to 0, but we don't have now just a product. We have a subtraction on the left-hand side. So still we can't use null factor law. Get to this stage, you're going to expand the brackets and then refactorize. So we get x squared minus 2x minus 1 equals 0. So we have a quadratic coefficient is equal to 1. So we should first try inspection. What are the factors of 1? Well, it's 1 and 1. Needs to be a negative and a positive 1. There's no way we can get that to make negative 2. So since inspection doesn't work, we're going to complete the square. So I'm going to do this over here just for some space. I'll do it in the... We complete the square of x squared minus 2x. Okay, so that middle coefficient term, if you remember back to the previous exercise, okay, this 2, we take the 2, we halve it, okay, and then we square it. So 2 on 2 is 1, and square it gives us 1. Now, how is this different to the subtract one? Well, we need actually a plus 1 there. Get a minus 1, and then our original minus 1. We needed a positive 1, not a negative 1 here to factorize this properly. So what do we end up with? We end up with, from this, what do we get? We get x minus 1 all squared. Minus 1 is minus 2, so we can write it as x minus 1 squared minus the square root of 2 all squared. So we'll use that over there, and now we have a difference of perfect squares. So x minus 1 squared minus root 2 all squared equals 0. So using the difference of perfect squares, if you haven't watched previous videos, you really need to. I'm not going to keep repeating that. X minus 1 minus root 2 bracket x minus 1 plus root 2 equals 0. So we're going to come over here. Therefore, x minus 1 minus root 2 equals 0, or x minus 1 plus root 2 equals 0. Follows on that x is equal to root 2 plus 1, or it is equal to x equal to 1 minus root 2. And there's our final solution. Okay. So this is hopefully starting to show you why have we been factorising all this time. We factorise because it allows us to use this null factor law. Now this whole section isn't just about the null factor law. There's other ways that we can actually solve equations. Okay, this section 5F is technically about solving. Null factor law is one method we can use. Okay, so we're going to practice we're going to practice a bunch of skills together. So it's saying solve the following quadratic equations: x squared minus 8x minus 20 equals 0. Well, to solve, we need to get in factorized form. That allows us to use the null factor law. So let's have a go at that. So we've got a coefficient of 1, so we'll try inspection. So 20, that will be a 10 and a 2, and negative 10 plus 2 gives me 8. So this turns into x, what I say, negative 10x plus 2, because negative 10 times 2 is my 20, negative 10 plus 2 is my 8, so that works, equals 0. Therefore, the 3 dots mean therefore, we can say x minus 10 equals 0, x plus 2 equals 0, x equals 10, or x equals negative 2. Okay, there's our solutions. Let's do this one. We have 6x squared minus 13x minus 5 equals 0. So we have a coefficient other than 1. That means we need to use the cross method. Okay, factors of 5 are just going to be 5 and 1. 6, let's see, is it going to be 3 and 2 or 1 and 6? Let's have a go. We need negative 13. 2 times the 5 will give me 10. And then 3 times 1 will give me 3. That can give me 13. But I need negative 13. Going to work. 3 times 5 will give me, yeah, if I do 3x times negative 5 is negative 15, and then my 2x, so plus, that'll work. Okay, 3x times negative 5 is negative 15x. That is equal to 2x. We add these together now, we get negative 13x, and that works. That gives me middle term. So we get a factorising of 2x minus 5 bracket 3x minus 1 equals 0. Therefore, x minus 5 equals 0. Then we just complete. So we get x equals negative 5 on 2 and x equals 1 on 3. There we go. We have done our solution. So the only thing extra in there was we started combining. We combined it using inspection with the null factor law, or in this case we used the cross method and then used the null factor law. Okay. So let's do a couple more practice. Okay. In this one, okay, and I've said this a couple of times, the very first thing you should ever look for is, can we take out the common factor? Okay, can we take out the common factor? In this case we can. I get x minus 3 equals 0. Now I have the product of two factors equals 0. I can use the null factor law. Therefore, x equals 0, or x minus 3 equals 0. So x equals 0, x equals 3. Okay, this one, x squared minus 7. Okay, what does it look like? What does it look like? Well, we can change this into square root of 7 squared. We now have a square minus a square. We have a difference of perfect squares. So this turns into x minus the square root of 7 bracket x plus the square root of 7 equals 0. Therefore, x minus root 7 0, x plus root 7 equals 0. So x is equal to negative root 7, or x equal to root 7. And you can write this solution as x equals plus or minus square root 7, because it's the positive and negative, it's the same thing. 3x squared equals 48. I can turn that into 3x squared minus 48 equals 0. Again, can I take out a common factor? We can take the 3 out. We get x squared minus 48 divided by 3. If I can get my brain to work, is that, what is that? 36 is 12. So 39 is 13. 42. that was 13, 14, 45 is 15, 48 is 16. Okay, so we get minus 16 equals 0. We can now write this as x squared minus 16 equals 0 because we divide both sides by 3. That cancels. 0 divided by 3 is still 0, so we get x squared minus 4 squared equals 0. So x minus 4 bracket x plus 4, we get x equals 4 or x equals negative 4. Now, in this first one, you notice if we don't have any coefficient here, if it's just a 1, we get x minus 3. The solution is always going to be this constant number with a different sign. So x minus 3, we know straight away the answer is going to be x equals positive 3, different sign. Same up here, we got x minus root 7. When we rearrange it, that means we're going to have a solution of positive root 7. If we have positive root 7 in the bracket, we know we're going to have a solution of negative root 2. So you can shortcut. You don't always need to write out this step here. Okay, it's good to get in the habit of when you're first at the start. It avoids sign errors, but once you get used to it, you get to this stage where you've got x minus 4, x plus 4. Well, my solution is going to be this with a different sign. Solution is going to be this with a different sign. You can jump straight to x equals plus or minus 4 as well. That's one way of just being a little bit more efficient. So, and this happened in class the other day when I was actually doing it with my class. Someone did this question B a little bit different, and they also did C a little bit different. Okay? But this question said use the null factor law. So to use the null factor law, you have to factorize and let it equal to 0. There is another way we can do it. Okay? So if we look at part B, we're looking at this one. There's another way we can do it. X minus 7 equals 0. We can let it equal to x squared equals 7. Therefore, x equals plus or minus the square root of 7, because we take the square root of both sides, and it's going to have a plus or minus solution. Okay? As it says here, though, the question asks us to use the null factor law. As to use the null factor law, we have to factorize to be able to do it. So you have to do what the question asks. So you've got to be really careful with reading the questions. So let's have a look at C. We can also do C the same way, though. So we had 3x squared equals 48. We can write that as x squared equals, what did we say the factor was? 16. So x equals the square root of 16 equals plus or minus 4. Okay, but that's not using the null factor, but it is quicker. There's 4 steps there compared to 1, 2, 2.5, 3, 4, 5, 6 steps. So that is quicker. Okay. Now, back on this whole topic, this section is solving quadratics. Solving quadratics. A lot of the time, we're not going to give it to you in the nice simple form of here, example 2a. We're not going to give it to you looking like that. It's not going to look like a quadratic. It's going to look something like A or B. Now you should be thinking, oh, what topic test have I got coming up? What topic am I in? What have I spent the last 3 weeks focusing on? Quadratics. So you should be thinking, this is going to be a quadratic. It's just hidden. It's just disguised. So how can we undo it? Well, this one's pretty straightforward. Equals 4x plus 4 times 8 is 32. We can turn this x squared minus 4x minus 32 equals 0. Now we have a quadratic that we can factorize, and it's asking me to solve. So I need to factorize and solve. This is going to turn into 32 factors are 8 and 4. Negative 8 plus the 4, that will work. Negative 8 plus 4. And that leaves us with, therefore, and I'm going to use the shortcut, since this term here is negative 8, my solution is going to be the same number but positive. Now this shortcut only works when the coefficient there is 1. Okay, if you've got something else, it's better to write it out in full. This one, x plus 4 equals 0, therefore x is equal to negative 4. Okay. Now part B, part B, 18 minus 7x on x equals x. We rearrange this by multiplying both sides by x. That cancels, so we're left with 18 minus 18 minus 7x equals x squared, so we get x squared plus 7x minus 18 equals 0, and negative 18, that'll be a 9 and a 2, most likely, and positive 9 minus 2, that gives me 18, positive 9 take away 2 gives me 7, so plus 9 minus 2 equals 0, therefore x equals negative 9 positive 2. There we go. And that is it for exercise 5F, solving quadratics. So we can use the null factor law. Some questions like this one here, we can actually just use symbolic manipulation, basic algebra to get the answer. You just got to be really careful with what the question says. If it says use the null factor law, you have to factorize. Otherwise, you don't have to. Any questions like normal, stick them on the Edmodo page. Thank you very much.